it's James. I just wanted to show you guys some projects I've been working on. Here we have a large capacitor and my multimeter and a Van de Graaff generator. Van de Graaff generator generates static electricity, which is not normally useful, but I'm going to show you guys how to harvest this electricity into a useful form and store it into the capacitor. This is not my idea, and it's not a new idea. This is the idea of Nikola Tesla, who is an electrical engineer and one of the world's greatest inventors. And in fact, he's responsible for creating household electricity, alternating current. So let me show you what we're going to do here. As you see, my multimeter is at the 0 setting, and I have it set to microvolts at the moment. That's quickly going to change. As you can see, the microvolts are climbing slowly right now when I unshorted this capacitor. That's pretty normal. What I'm going to do here is I'm going to take the top off this Van de Graaff and hook up the positive lead of the capacitor wire to the collector on the Van de Graaff. And all the static electricity that's being built up on the collector is going to go to the positive pole on the capacitor. And the negative pole is going to be the ground, which I have hooked up to this cooking unit. Of course, it's not on. In fact, I even got the circuit breaker turned off just to be safe. So now I'm going to plug in the Van de Graaff and show you what happens. As you can see, the microvolts are going up, and it's going to continue to climb for a few minutes. So we're currently at 700 microvolts, climbing to 8, 9, and basically, so this is a way of collecting static electricity and collecting it in a capacitor to be used for DC electric systems, or used for charging batteries. It's a small voltage, but it demonstrates that power can be collected from an unconventional means. Now you can see my multimeter is tapped out. It's no longer able to read in the microvolt range, now it's in the millivolt range. If I continue to let this go, and I'll walk away for, let's say, a half hour, it'll get as high as 10, 15 volts. Now I know I'm using electricity from the Van de Graaff to, produce the static, but the static is naturally occurring in nature and can collect slowly on the capacitor if you had an antenna hooked up to where the positive lead is and a ground wire hooked up to the negative. So anyway, so that's that one. And we're at 400, excuse me, the glare from the light, 400 plus millivolts. And I'm going to stop this to show you my next project. Alright. As you can see, the Van de Graaff is turned off and the voltage is at 450 and dropping. But for my next project, I'm not going to use this large capacitor. I'm going to use a voltage doubler circuit, which is this guy right here. Now what this will do is basically, it's a really neat little circuit. It will take electricity from radio waves, static, whatever and convert it to usable electricity that's stored in these tiny little capacitors. So if you hold on just a second and let me fix my wires, I'll show you that. I know it's a bit of a wiring mess, but I wanted to show you how this works. Now, this is a very efficient way of collecting electricity, and it's much more helpful. Much more helpful for collecting juice. So, I have my leads hooked up, positive to this left part of the circuit, and my negative lead hooked up to the right part of the circuit. Ground is hooked up to this middle wire, this bottom wire, and the sky or Van de Graaff is going to the top wire. Currently, my millivolts are reading in the negative, so I'm thinking I may have this hooked up backwards. Yeah. So let's switch those out. So ground goes to the top wire, and sky goes to the negative. Still not right.